Hello. So in here we are going to do in unbalanced three-phase loads. Unbalanced three-phase loads. Okay, just to talk about the unbalanced, kweza video le you should watch. I was talking about a balanced load, whereby the current drawn by each phase is the same. So up, this is not the case. A current drawn by each phase is not the same. Okay, current is not the same. Okay, so the current drawn by the red phase is not equals to the current drawn by the yellow phase, and is not equals to the current drawn by the blue phase. I wanted to write there, sorry. Then the impedance of each phase is not equal. Okay, this is a direct opposite of a balanced load. Okay, and a power drawn by each phase, the power drawn by the red phase cannot be equals to the power drawn by the yellow phase, and it cannot be equals to the power drawn by the blue phase. That is why we call this type of connection a three-phase unbalanced load. Okay, but ke ngoku esizoqala sithethe ngayo apha three-phase, the first unbalanced load we are going to talk about is your star connected load. Okay, how do we do a calculation on a star connected load that is unbalanced? That is unbalanced. Okay, this is how we do the calculation. Basically, I guess it's the same way we're doing a balanced, but now the only difference you would note about a unbalanced any unbalanced load is that the impedance, the current, the power of each phase are not the same. Okay, two of them can be the same. Let's say a current ka red phase no yellow phase siyalingana, but immediately a current ka blue phase yona ingalingani nezezinye. That means we are dealing here with the question of an unbalanced load. That is how we tell that we are dealing with an unbalanced load. Either the currents are not the same, the impedance are not the same, the power of each phase is not the same, then it's an unbalanced star connected load. So I'm gonna use an example here to try and explain what is happening as I'm reading through the question. Then you'll attempt the activities. And the reason I'm also doing example is because I don't have a handheld calculator, but I want to give you a chance to do activities by yourself then. But once I go through these examples with you, you'd see that this thing is not that difficult. Okay, so I'm gonna read example 2.2 up in front of me. The example: a three-phase unbalanced star connected load is supplied from a 380 volt 50 hertz supply. The impedance of each phase is as follows. Look at something here. The impedance of the red phase is 12 plus J, 10 ohms. Then of the yellow phase is 25 minus J, 30 ohms. You do see that the red phase and the yellow phase don't have the same impedance. Immediately, that also tells us on the dot that is an unbalanced load. Unbalanced load leyo. Yabo, impedance ka phase being 18 plus J 0. Take UVR as a reference. Use a phase sequence of R, Y, D to calculate the phase currents. Okay, that is question number A. They want us to calculate the phase currents. Or question number B wants us to calculate the line currents. Then C wants us to calculate the power drawn by each phase. D wants us to calculate the total power drawn by the load. Or E wants us to calculate the current that flows through the neutral conductor. And also I forgot to mention best we balanced we balanced sithe i-current eflowa ku-neutral. Xa i-balance, i-current ezoflowa ku-neutral is equals to 0 amps, and the current eziflowa ku-neutral we add isum zezi current. We're gonna siyibala njani current eflowa ku-neutral ku-IR, current of the red phase, IY plus IB. So you add all the currents and to calculate the current in the neutral wire. But when it is a balanced load, that current will get ubani was 0 amps. But if it's unbalanced, in current in the neutral cannot be equals to 0 amps. Okay, that is another thing I forgot to mention as I was beginning the video. Okay, your solution must be accompanied by a vector diagram showing the voltages and the currents. So I'm going to read through the question again and write down the givens and explain what is happening. Okay, I like classes sense a question, a calculation efundisayo uba siqale siyifunde yonke equation qala, so that we can have an overview of what is the problem apha kule question and what are we given and what are we required to calculate. Yeah, but many idea about okay, what are we doing here? What are we talking about? What is the subject all about? Yeah, well, question. Okay, so the subject is about a unbalanced star connected load. Okay, so as you read through, you're gonna write well, okay, but a three-phase, so three-phase. Okay, I use this to just to show that it's a three-phase. Yeah, well, unbalanced star, it is a star connected load. It's a star connected load. Okay, that is a symbol for a star. It's supplied from a 380 volts. A given voltage is always the line voltage. Given voltage is the line voltage, which is 380 volts. Okay, then but if 50 hertz, F is equals to 50 hertz, that is the frequency. Okay, then sanikwa the impedances. Ega red phase impedance ku 12 plus J 10 ohms. Ega yellow phase impedance ku 25 minus J 30 ohms. Then ega B ku 18 plus J 0 ohms. Okay, equation ithini ithini question? I-question ithi basisitake uVR as a reference, meaning ke ngososebenza the phase sequence ethi R Y, oh sorry, ayibhale kahle le pen, R Y B, meaning ke ngoku so hamba le phase sequence ke ngosisi wami, ne? Meaning kule phase sequence, kwi-phase sequence leyo qala mos siyithatha as a reference, meaning i-voltage of the red phase. Notice I'm putting P just to show that xa sibala nge-phase values, asibali nge-line values. Okay, ku-red phase ndizothi i-voltage yakhe, i-voltage ye-red phase, ne? But i-angle ndifaka bani? U0, ndihamba ngekwe-sequence. Then elandelayo ngokwe-sequence yam ngu-Y, kulandela u-Y. Then u-V P Y izoba ngu-V P Y, i-angle ndifaka bani? U-minus 120 degrees. Then after u-Y kulandele bani? U-blue. Okay, kwi-sequence yam. Then zoti V phase B, then V phase B, but ke ngoku angle yakhe ndizoyibhala as 120. So ndihamba ngokwale sequence. So how do we then draw this, what I've just written now? Okay, you're gonna draw your vector diagram. Okay, vector diagram assists us to solve these kind of problems. Yabo, it assists us in solving these kind of problems. Obona ka sibala a power factor, where we are looking at the current between that phase, where we are looking at the voltage between where we are looking at the angle between the current and voltage of that particular phase we are calculating the power factor on, because each phase nganye ine power factor yayo. Okay, so nango reference V phase R. Okay, yabona ndibeka kunoni kwi-reference line. So kasidila a-vector diagram, the horizontal line is always the reference line pointing to the right. Then 80 minus bani 120 degrees, 120 degrees, that is the yellow phase, V phase Y. And notice xa ndithi negative angle, I rotate clockwise from the reference. Yabo. Then enye ithi positive, so I rotate anti-clockwise 120. This is the blue phase. Okay, fine. So i-question yam ithi yona mandibale intoni i-current, i-phase current. I-current ke siyibala nge-Ohm's law. Ayikho nje enye iformula yobala i-current, that is Ohm's law qha. We use Ohm's law. It is the voltage divided by the impedance, because kaloku sithetha ngo-AC. We cannot say voltage divided by resistance. There are two opposition to a current flow when you're talking about AC. That is resistance and reactance. Hence we say ke ngoku Ohm's law, where AC, it's voltage divided by the impedance. Okay, so I phase R, remember sibala nge phase values, so values ozozifumana ze phase values, V phase R over Z R. So into ezoyenzeka ne uzoqala the first thing that you're gonna want to do is to convert lo 380 line voltage, that's 380 line voltage into a phase value, yeah, by saying the line value. Remember, just converted to a phase value, it's what? A line value divided by the square root of 3. So we're gonna say 380 divided by root 3. Okay, so basically lento nansi ilapha ne encwadini. Okay, so we converted that 380 safumana u219,393 volts. Okay, says then ke uyifumane a phase voltage, then go a phase voltage uzoyibhala ngokwe sequence ne for each phase. Ungathi uV phase R kubani u219 bese angle ye red phase sorting bani ku 0 degrees. Then same thing you could do for yellow phase na bese 219 na, which is the voltage, but ke ngoku what is the angle for yellow phase, because it is the next one elandela kwintoni kwi-sequence yethu sothi minus 120. Then V phase B 219,393, then angle sothi 120 degrees. Okay, also now, okay, you do that now. How do we calculate a current? A current te voltage over impedance. So you're gonna calculate the current when for each phase, meaning a current for the red phase will be voltage red phase divided by impedance red phase. A current yellow phase will be what? Voltage yellow phase divided by the impedance of yellow phase. Remember, get before uzo bala, you convert impedances. These impedances, and it is negative, but it is in polar, in rectangular, and we're going to perform a division. We must first convert these values into polar values, because we're going to divide here. Nanzi following through the example, bas converter, then babala a current for each phase, which is voltage red phase na impedance red phase. Then bafumana red phase bafumana 14,046, the angle being negative 39,806 amps. Then I want to explain the vector diagram after we as with the current. Wabala ke sabala ke ngoku current in the yellow phase using the voltage of the yellow phase and the impedance of the yellow phase. Then sabala a current for blue phase using the voltage of the voltage of the blue phase divided by the impedance of the blue phase. Okay, safumana bani 12, that is 12,189 angle 120. Okay, the second question wants us to find the line currents. Okay, remember, as the values sigqibozibhala ngoku first question phase currents, yeah, phase currents. Remember, xa ubalayo ngeformula ufumana line values ne obala, and it because you're doing calculations, ufumana phase values. Sorry, let me refresh that statement. Ufumana phase values. Remember, xa senza a calculation sibala phase values, so values also sifumana phase values. but ke ngoku ubi wants us to find the line value. I-line value ke sisiwam in terms of the current, in terms of a current kwi-star connected system, line current no phase current uyathini akachange. So basically kula question kucheckishwa nje uba kucheckishwa nje i-knowledge uba do you know that kwi-star connected system i-line current ne-phase current siyafana. Hence ke ngokubona kule solution kuvele kwathiwa IRR prime. Okay, once ibene prime, it means this thing is just a notation. It doesn't matter how you put it when. Yeah, but for example, benoti ILR in brackets is equals to IP, or P meaning phase, R in brackets. Okay, the current of them, the line current and the phase current are the same in a what? In a star. Then it calculates, okay, that value bendiyifumene ibe 14,046 angle minus 39,806. Yeah, then line current yellow phase is equals to phase current yellow phase. Okay, kanjalo. What is important is knowing that the current of the in a star connected load, the line current and the phase current is the same. So isekwazizo as values line currents. Yeah, then the next question wanted us to calculate the power drawn by each phase, and besichilo ke sisiba kwi unbalanced load, power drawn by each phase is not the same. So if ndifuna ubala power, the best formula to ubala power without having to worry about the angle endiyithandayo nansi. Xa ubala ngale formula, power is equals to I squared R. You don't have to know the power factor, you don't have to know the angle. You just have to know the current of that phase and the resistance of that phase. How do you see the resistance of a phase? If you are given impedance, remember, if you are given impedance, for example, impedance ka R ite 12 plus J 10 ohms. I-resistance la 12 la term ingena J, i-resistance, yabo, which is 12 ohms. So if I'm going to use this formula, so that power of the red phase is the current of the red phase squared, then it be resistance of the red phase. Yeah? The resistance of the red phase, which is a current of the red phase, we calculated as 14,046 squared. Resistance, you go to impedance.